Frogs are an integral part of a healthy ecosystem. In Australia alone, we have over 200 different species. These endearing animals are not only iconic, but are woven into our culture and history. Over the last 30 years, many species have simply vanished.
So in Australia, frogs started declining at the end of the 1970s, and all through the 80s, frog populations disappeared, and most of the time no one was around when these populations crashed. So within a few months they disappeared, and biologists would turn up and the forests were quiet, and there was a big mystery about where the frogs had gone. It wasn't until the 1990s that Keith McDonald, the Chief Ranger of Queensland, asked Rick Spear from JCU to help him work out what was going on, and they started intensively monitoring some populations up near Cooktown, and they were there at the time of a die-off, and so they were able to collect freshly dead and sick frogs and brought them back to the university for post-mortems. And that's when I became involved as a student to work out why these frogs were dying. And we saw this unidentified sort of round fungus in the skin. We weren't sure if it was a fatal disease or not until we managed to transmit it to other frogs, and when they all died we knew that it was actually a really pathogenic disease and causing the mass die-offs in the wild.
The disease is now known as amphibian chytrid fungus.
The amphibian chytrid fungus is the most deadly disease ever described in animals. It has caused hundreds of amphibians to go extinct all over the world. And no one has come up with a solution, even though this fungus has been known for about 30 years now.
So the frog chytrid fungus, it grows as spherical sporangia, so this is the fungus in culture. When it's mature, it grows these discharge tubes, and these little spores that swim are released out of them. In frog skin, it just grows on the very superficial layers of the epidermis, so just on the top of the frog skin. You can see these are all the fungi here, and some are growing the spores. And here's one with a tube that pokes out to release the spores. And in a mammal, this wouldn't be a fatal disease, but in frogs, because their skin is so important, so many functions in maintaining their homeostasis, that when they get infected, the skin function is disrupted.
Here at James Cook University, a team of scientists are racing to find a solution before it is too late for species like the corroboree frog.
So the overall aim of our research is to improve survival rates of frogs in the wild. And so we think there's 6 species in Australia their populations are so small that without intervention they will go extinct. And so our aim is really to try and stop their extinction.
So the reason that we've chosen the corroboree frog for this research is this is Australia's most endangered amphibian. There's less than a handful of these frogs left in the wild. And the reason they've been driven extinct is the introduction of the chytrid fungus by humans. And now there are probably less than 10 individuals left in the wild. So what we're doing with the corroboree frogs is a genetic study to see if we can find certain alleles that are associated with disease resistance in these frogs. And then we're going to use this information to improve the captive breeding program so that chytrid-resistant frogs can be released into the wild.
Without this research, the corroboree frog and similar species are likely to go extinct. However, funding for the project is running thin.
So you're asking for people to help us to keep this research going and to expand the research, because it's really useful research that we're trying to do. And at the moment, it's actually getting harder to get government funding for public good research. A lot of the research that's favoured at the moment is about things that will make money, and we're never going to do that.
So our research is not just useful for corroboree frogs, but for threatened frogs and wildlife worldwide. Emerging infectious diseases are threatening all kinds of wildlife, including frogs, bats, and even an endangered species of antelope. So we think that our methods can be used as a proof of concept for saving threatened wildlife all around the world.